In this example, we see that crosstalk failed with a margin of minus 1.3 dB. That red asterisk to the right-hand side indicates it's a marginal fail. That's within the accuracy of the instrument. When it comes to failing, a fail is a fail, so we need to diagnose this. If we tap on near-end crosstalk, what's going to happen here is in this particular example, it's jumped to the 6 measurements made from the far end. Crosstalk is made 6 measurements in one direction and then 6 in the other direction. And we're interested in finding out which is the worst performing pair, because that's the one we want to diagnose. If I tap the pair arrow on the right here, we see that it's actually pair 3645. It could be 1278, it could be any of those combinations. There's not too much more to be gained from looking at this graph in terms of diagnosing crosstalk. I mean, we can see that it failed at the top end of the frequency range, around about 500 megahertz. Let's remember that 3645. Let's go back to the home screen. We have a diagnostic tag, and we have two options on there. We have HD TDR Analyzer and HD TDX. The R in the HD TDR, return loss, the HD TDX, crosstalk. Of course, the purists out there will say TDR does not mean return loss. You're absolutely right, it means time domain reflectometer. But it's a good way to remember which one's for return loss and which one's for crosstalk. Let's tap the crosstalk diagnostics. You're immediately presented with a time domain plot. That is the ability to actually look down the cable and see where the crosstalk is happening. And it's going to show all 6 pairs. We're only interested in that pair that caused us the problem, which was the 3645. So I'm going to go using that pair arrow, so I get 3645 appear in the top left hand corner there. The cursor will automatically go to the largest source of crosstalk, and it's gone to around about 51.4 meters, 168 feet. This is the far end connection here. Down here we see a value of 45.7. That's 45.7%. That's relative to the vertical scale here. What does that mean? In an ideal world, we're looking for better than 30% where the connections are. 30 to 35 is ho-hum. 35 to 40, you should start getting nervous because you're going to start seeing a reduction in margin on your near-end crosstalk test. And generally, anything over 40 suggests that something didn't quite go right during that installation. When we look at this one here, the far end connection is reporting 45.7. That's simply too much crosstalk going on in that remote connection. Now, there are two possible causes there. It could be a termination issue, or it could be a non-compliant connector. Now, we know for a fact in this one that the connector they installed was actually a true Cat6A connector. So that means it's probably a termination issue. The good news is we're not dealing with a cable issue, because when we look down the cable, we don't see anything. Now, normally you would see a few bumps going down there. The general rule within the cable is if the event, the spike, is more than 10%, be a little bit concerned. If you get more than 4 or 5 of those, then you're going to start to see a bit of a cable issue happening, but we don't see anything like that here. Now, before we go off and re-terminate the far end here, we should probably check out our near end connection here. So I'm just going to move my cursor all the way over to the right here. And I put it to where my first connection is, and it's showing a value of 33.7. Now, some people have interpreted my knowledge base articles as, well, if it's not 30, then it's a fail. No, that's it. This is purely a guide. So at 33.7, it's ho-hum performance, but the far end is where our problem is. So the first thing I would do is re-terminate the far end. And indeed, in this customer, when he re-terminated the far end correctly, the margin came up and he got a very good pass. That is how you diagnose a termination issue on the DSX 5000 cable analyzer that caused a crosstalk issue.